Welcome, everyone, to Hot Science at Home. Whether you're coming from the Sustainability Symposium today or elsewhere, we're really glad you can join us tonight. University of Texas at Austin's Environmental Science Institute is proud to bring you the latest and coolest advancements in science through Hot Science at Home. We would like to welcome everyone watching on YouTube and Facebook. And tonight, we're delighted to have with us Dr. Monica Ramirez. Welcome. Dr. Ramirez is a professor of environmental science at the University of Arizona. And early in life, Monica saw herself as an artist, but her family and her parents were more interested in seeing her become a doctor or a lawyer or such. She then began seeing how people were connected to ecosystems and the services ecosystems provided. She began thinking maybe a career in science was in the future for her through that. And so before we actually get started talking to the professor, we're going to encourage you to enter your question at any time during the talk, and we'll ask as many of them as possible during the Q&A session afterwards with Monica. And so please submit your questions right through Facebook or the YouTube comment section. So, Professor Monica Ramirez, please tell us about yourself.
Well, first of all, thank you so very much, Jay, for the invitation. It's an honor to be speaking to all the families and everyone out there on this Friday evening. So I'm Monica Ramirez. I'm second generation Mexican-American in Tucson, Arizona. My grandmother said that while she was in labor, she literally held my dad in so she could cross the Arizona-Mexico border or Mexico-Arizona border so that my dad could have U.S. citizenship. So I'm very honored to be here in the United States and be a professor at the University of Arizona. My hometown is Tucson, Arizona, and that is within the border line or border boundary, which is the symbolic boundary reminding us to protect, conserve, and improve the environment. So I grew up in the Sonoran Chihuahua Desert, which is one of the top 100 ecosystems. And growing up, as you heard Jay talk about, I was interested in the arts, and I actually have an art degree, but pursued the sciences to make a living, but also make a difference. And so I'm excited to be here today.
Thank you for being here. So, Monica, please tell us, what evidence is there that there's environmental injustice on a large scale in this world?
Yeah, so what we know, right? So a couple years ago, a Lancet report came out documenting that pollution is the world's largest environmental cause of disease and premature death. So what does that mean? That means that the exposures to contaminated air, water, and soil kill more people than a high sodium diet, obesity, alcohol, road accidents, or child and maternal malnutrition, right? So environmental exposures play a substantial role in health, and they play a substantial role in the disproportionate burden of disease experienced by certain communities. And so I got involved in this because my objectives are to pioneer new skills in exposure science and communication to mitigate and prevent these adverse exposures, right? And I'll be talking more about that here today.
Well, what originally motivated you to get into this kind of research?
Yeah, so I think that what originally motivated me was this of seeing how, again, bringing up like where I grew up in the United States in a border region as well in Mexico, is seeing the interconnectedness and dependency on ecosystem services and seeing the differences in access to information and social justice issues. So while my family in Mexico very much relied on fishing in this major river, when that body of river went down, the level of that water went down, they changed their occupation to ranching. And it was at that moment I saw that interconnectedness between ecosystem services and vitality. And so I basically bared witness to social and environmental degradation, which completely changed the way I saw and experienced environmental health. What you see on the slide today, right now, is a map showing all the different federally designated cleanup sites. And so what you can gather from this map is that contamination is prevalent, right? We know that 1 in 4 Americans live within, if you want to hit that slide, show me that statistic, right, are living near a hazardous waste site, right? So 1 in 4 live within 3 miles of a hazardous waste site. And what this means to all of us here on this call and across the United States is that your zip code can be more important than your genetic code. It was originally thought that your genetics would dictate your health outcomes, but now we know that what you look like, who you are, will dictate health outcomes. And so in general, right, what's motivating me is I'm striving, right, for environmental justice, right? Students in my lab, my colleagues, we strive for justice. Oh, that's okay, you can go where you were at. And so when we're striving for justice, we are trying to ensure that there's fair treatment, meaningful involvement of all people, right? And this is the spirit in which we want to operate, and we need to celebrate this idea of all involvement in the development, implementation, and enforcement of laws, regulation, and policies. And the reason why this is so critical is because we are living in a time where justice is not being achieved, right? And so when we think about it right now, the data shows us we have tremendous amount of evidence-based information showing us that if you're a low income and or minority or a tribal population, you are disproportionately exposed to environmental pollution, right? And so next, if you hit that slide for me, you can see that right here is an image. If we look at this image, you can see that people are laying across the road. This is an image from 1982 showing protesters lining the highway trying to block the dump trucks loaded with a contaminated soil, right? And so these are people of all religious groups, all color and races coming together to try to advocate for environmental justice. And this actually, this activity that you're seeing right here was the beginning of the environmental justice movement, that social movement. And just to hone in very specifically is to let you know that however, like the protests occurred, but they did not stop the trucks from rolling in and dumping their loads. And so they brought in about 6,000 truckloads of contaminated soils. And just 2 weeks later, more than 414 protesters had been arrested. The protest demonstrations in Warren County marked the first time anyone in the United States had been jailed trying to halt a toxic waste landfill, right? So this was a monumental period in our history. And so when we think about this, we not only think about income and minority, we have to think about lack of privilege, limited political influence, linguistic isolation, and access to information to account for all racial groups when we think about achieving justice.
Yeah, well, certainly lots to motivate. Particular examples, things happening across the scale of our nation. So much to motivate one to pursue research in this area. So, what research projects have you been developing?
Yeah, so I work alongside and in collaboration with community members who neighbor hazardous waste sites or live in an environmentally compromised space. So while meeting people where they are and acknowledging that they're experts in their own right, remembering that they too, like I when I was young, are bearing witness to environmental health issues, they bring up environmental health research questions and we work together to answer them. So we use a co-created citizen science or community science approach. Community members are involved in all or most of the steps of scientific research. And so what you see here is like in Garden Roots, one of the co-created citizen science projects I have, community members are asking, are my soils safe? Is it safe for me to consume the vegetables from my garden? If so, how much? In Project Harvest, another citizen science project, community members are doing the right thing, right? They're advocating and, no, you're okay, you can go back to where you were. Project Harvest community members are asking about, they're harvesting rainwater to preserve water, right? We're in the arid, semi-arid Southwest. And they're asking, are there pollutants in harvested rainwater? If so, do these pollutants get trapped in soils? And so here's an example, right, of some of the selected communities in which we're working with. You can see that these are rural mining communities. They either are neighboring active or legacy mining. And we're also working in an urban setting, looking at communities that are neighboring toxic release inventory sites.
Yeah, so what are some of your findings regarding what we're consuming?
Yeah, so if we want to hit to the next slide, one of the no, you can go right back there, no worries. All right, here we go. So one thing I just wanted to highlight here is this is an example of the type of the participants in Project Harvest, for example. And so these participants are from environmental justice communities, right? So they live near sources of hazardous waste or toxic release inventories. And as you can see, over 50% are low income minority and do not have a college degree. And so I want to highlight here that typically, so this is a social science result for you, Jay, right, before we get into the environmental monitoring data. But what I'm excited to show you here, right, is that citizen science programs typically do not reflect this level, this type of demographic, right? And so the reason why we're seeing this type of demographic in the projects that are coming out from Gardens and Project Harvest is because research questions are stemming from the community and we're working in tandem together. And so it's exciting to when we asked about self-efficacy for learning and doing science, we saw no differences based on these socioeconomic status factors, showing that anyone can do citizen science. And they do not predict, your demographics will not predict your success as a citizen scientist.
So your research is a really interesting combination of both social science and environmental science, both people side and the technical side of things, which is so important in trying to address some of these issues that you've been so motivated to get after. So bring us more to the environmental science side of things now.
Yeah, so now we look at the participants and people. So if we go to the next slide, what we see here is one way, right? So we have so much data. First of all, I just have to say, like, it's so exciting. And I very much look forward to opportunities to like sitting in the dark with the data, marinating and like looking at figures to see patterns, okay? And because you really want to look for those patterns to tell the best data story you possibly can, right? Because you have to speak for the numbers and what you're observing. And so with crops, one way we can do this is by evaluating bioconcentration factors, which describes the ability of the plant to accumulate or take up into the edible portion, what we're interested here, the element contaminant, or in this case, the metal. And so what we do is we look at the concentration in the metal, concentration of the metal in the plant or the crop, and we divide that by what the concentration of the metal in the soil. And this allows us to look at the metal concentration across all the crops. And so next slide,
Yeah, show us some of your findings, please.
Yeah, so here we go. Okay, so these are, here you're seeing two figures showing the bioconcentration factors for different types of crops and plant families. So they're represented in the different colors. And as you see on the x-axis, we've given you some examples of the plants that were submitted by community members. But one thing we like to do is test the hypothesis of, do plants within the same plant family accumulate these chemicals in the same way? And so you can imagine, like, do you and your brother and sister, your cousins, operate in the same way? And so we're kind of thinking about that when we look at these plant families. And so the box, these figures are what we call box plots. And so the boxes that you see represent the 25th and the 75th percentile range of the data. And then the line within the box, right, is the median. And the outer lines are min and max, and all those little dots you might see sprinkled about, those are what we call outliers, ones that were like totally out of the range that you see and within the min and max that you see by the whiskers. And so looking at this data set, we can first look at cadmium. So cadmium is a heavy metal, and we can see that a few of these plants accumulated arsenic. We see that the lettuce, right, that's represented here in the green, the lighter green, which is part of the Asteraceae family, and kale and broccoli, which is part of the Brassicaceae family, accumulated more cadmium than other families, with carrots and cilantro not far behind. Particularly, we see these crops possibly hyperaccumulating, right? Meaning that they had much higher concentrations of cadmium in the edible tissue than the soils in which they were grown. Now we can move,
Yeah, so you got cadmium, you've got arsenic. What's so bad about a little bit of extra cadmium or arsenic in your diet? What's the deal with these elements?
Yeah, so this is where we are very much concerned. So looking at arsenic, particularly inorganic arsenic, we know that exposure to arsenic can lead to cancer and non-cancer health outcomes. So exposure to arsenic has led to bladder cancer, skin cancer, and non-cancer health outcomes have been associated with arsenic exposure are tied to potential diabetes and obesity and some other issues. So we are very much concerned about human exposure to heavy metals like cadmium or the metalloid like arsenic. But I want to highlight that right now we're just looking at the plants, right? We're looking at a bioconcentration factor. This is looking at what was in that edible tissue, which is one exposure pathway, right? And so as an environmental health scientist, right, I do exposure science. I look at how humans can be exposed to pollutants in the environment. So what's not shown here is their ingestion of water, incidental ingestion of soil, inhalation of dust, and air quality. But you can see here that from this graphic, if we go back to the plants, you can see that these plants are accumulating at different levels, and that you would have to understand these accumulation patterns and then tie that in and combine that with consumption rates, right? And how families are consuming from their gardens. And so you can see that just by comparing, and so not only can you compare the different plants, but now you can compare the two metals that might be in that plant and how they're accumulating differently. So you see that arsenic is accumulating a different rate than the cadmium here.
So, okay, in a bigger picture now, how does your research on exposure science and environmental science, how does that combine with citizen science research? And further, how do all those combine with community? How does that all come together?
I know. It's a really exciting place to work. I think tying to the beginning of the talk, right, when we talked about like my dad guiding me and what I was going to become and these life experiences. So for everyone out there who's wondering like this, it looks like you have this linear path. It is not linear, right? I have a undergrad in ecology and evolutionary biology. I have an art degree. I have a minor in Spanish. I have a policy administration degree from Columbia University, a PhD in environmental science, and I minored in art as a PhD student. So you can make your curriculum as you want it, because for me, I'm a transdisciplinary researcher. I want to solve problems. And to solve problems, you have to dissolve boundaries, dissolve barriers between boundaries, cross-pollinate stakeholders and disciplines. And so that's my personal statement about how I educated myself formally and informally. But to wrap up this talk and then look at how all this comes together is to, number one, right, apply an environmental justice framework, right? So work to uncover the underlying assumptions that may contribute to and produce unequal protection. So you can hit that slide for me. This allows for one, not only to account for the interrelated effects of culturally diverse and economically disadvantaged groups with toxic exposures, but it proposes solutions that foster change at the structural level. So just think about the social climate that we're living in right now. We want to see change at the structural level, at the institutional level, right? And so problems of environmental, social, and economic complexity require these new forms of investigation in environmental health sciences and require the cross-pollination and collaboration among stakeholders. I also advocate for the co-created community science approach. Work in collaboration, co-design with impacted communities. This helps ensure that you can see changes in environmental health literacy, right? And co-learning among all, not the academics, the citizen scientists, and the co-researchers. If we look at number 3, right, I am building, I'm building off of existing relationships I've had with the communities, but I advocate that you build relationships and have research questions stem from the communities in which you're working with. Participants from communities of color are more likely to be motivated to address a relevant problem or because of a prior relationship and because you're dealing with an issue that they deal with daily. Number 4, right, as I just talked about, I showed you some plant data, but we need to be aware that exposure pathways and concentrations can vary by media, right? And so here we can think about and that each community has their own idiosyncrasies. And so even though I work mainly with communities neighboring active or legacy mining, the environments and chemical concentrations vary as well as the primary exposure routes. But then on top of that, each community has its own culture, its own social ecology, and idiosyncrasies and nuances. Like, for example, in one community, they've been living there for 5 to 10 generations. And so this is important information when doing an exposure assessment. And number 5, which I didn't go into too much detail, but I spend a tremendous amount of time on data visualization and data sharing and communication, right? When you're working to increase environmental health literacy, which means this knowledge and awareness of environmental exposure. You want to build skills and efficacy to protect health and community action to protect the collective health, right? So not just at the individual family level, but the collective level. And for this to occur, we use a cultural model of data sharing and risk communication. And this needs to occur to ensure the evidence-based information and the research is translated into action, which that is a key thing that community members like to see. And so do I as a researcher.
Wow.
And so, yeah.
Thank you. That's a very comprehensive look at how it all fits together. Excellent. Thank you so much, Monica. Who would you like to shout out?
Oh, man. Yeah, I mean, so many people to say thank you to. So massive thank you to all the Garden Roots and Project Harvest participants, the promotoras, the community health workers who are the knowledge brokers and liaisons between the university and the communities, all the students in my lab who have been working on this project and working on this work since 2015, the Project Harvest research team, right, consisting of tons of great people. Here you can see the logos and the people, right? So this takes a good amount of energy, humans, and funding to do this type of work. So if you wanted to follow up on the projects I mentioned today, I put the websites on the lower left corner, Garden Roots and projectharvest.arizona.edu.
Outstanding. Thank you so much. Are you up for taking some questions from our audience?
Of course I am. Just going to take a sip of water.
Okay. Well, the first question comes from Eliana Pat. And Eliana asks, what are some environmental challenges that you think don't get enough attention?
That's a big one. I think, right, one of the things, environmental challenges that don't get enough attention. So I might be biased, but as someone who studied soils, right, soil health is so critical to not only climate change, carbon sequestration, and other issues, but to agriculture and nutrition. And so I think that sometimes soils gets, the skin of the earth just doesn't get enough attention sometimes. But that's how I answer that right off the bat right now. But I'm sure others might have some ideas. Jay, what about you? Do you have an area that you just wish got more attention? Not to redirect to you.
Yeah, no, it's remarkable. Just this class I teach, Sustaining a Planet, we go through them all. And whether it's climate, fresh water, the oceans, I think the oceans in particular are, because it's so vast and deep and seemingly limitless, that we don't really have full knowledge or consciousness about it because it's so much hidden from us, as opposed to these communities, which is great, right? Because you could have a very visceral reaction to seeing data like yours saying, wow, that's in the soil that I'm growing my vegetables in. Yeah, but the vastness of the oceans make it so much harder to appreciate, I think, the impacts that we're having on them. Yeah, I
mean, one thing related to vastness and maybe invisibility is like air quality. And so one of the things right now under the Clean Air Act, so this is another area I would say, like under the Clean Air Act, we just regulate 6 criteria air pollutants, right? And if we look at particulate matter, it's only regulated at 2.5 microns, right? Like 1/25th or 10th of your hair, right? And then particulate matter at 10, but you just look at the total. You don't do any what we call chemical speciation. So you just look at the total amount. You don't actually look at the chemicals that are in that particulate matter. So this is an area that I think needs more attention because we are inhaling these particles. And if there is a chemical or element like arsenic attached to that, could that cause damage to or that is an exposure route, right? And so I think that we need to do more chemical speciation with particulate matter under the Clean Air Act.
Mm-hmm. Yeah, right on. Yeah. Let's see. Comment from Gabrielle. She says, hello from Houston. Okay. Well, let's see how right people. We have someone from South Austin, someone from North Austin, and so far Houston's as far away as we have reached. Let's see. Katerina asks, what are some tips you have for people trying to learn more about sustainability and helping the environment?
Well, one of the things that I think help out with sustainability, to learn more about sustainability, there's so many different aspects to sustainability, right? And there's been different types of definition proposed. And so one way of thinking about sustainability is like making sure that future generations have the resources that we have today. Another way of looking at it is the triple bottom line, right? That we have economic prosperity, social prosperity, and environmental protection. And so when you think about it in those 3 ways, you can get involved in sustainability in a lot of different, I would say like one one of the things like in Tucson, Arizona, right, is we have a water management group. We have our city of Tucson that's providing a water rebate program for people who want to start rainwater harvesting or who want to have low flow toilets, who want to use less energy in their homes. And so you could do something at the local level and with your own infrastructure. You could get involved in different types of state, community, and public comment meetings, right? So that's one thing that maybe not everybody knows about, but your state department has to let everybody be aware of community meetings and public comment periods for changes or new proposed legislation or permitting for activities in your area. And so you can be involved in that by keeping a pulse on your state Department of Environmental Quality's website, and you can participate in those public comments. You can give comments about the permitting, and you can participate in those meetings. So those are some ideas regarding sustainability, but that's a few, right?
That's a few. And if they get really motivated, maybe they could apply to the undergrad or graduate program at the University of Arizona's Department of Environmental Science.
Of course. Thank you for that plug. I mean, why not? Come be a gato, right? I'm a gato for life, right? I mean, so I would say like you're welcome to come study. I mean, that is one way to contribute as well, of course, is you could dedicate your academic and professional career to this. But the one big thing I want to highlight is the conversation. The conversation. So this hot science at home that you have that Jay and D-Day and this department is hosting is a very, very important piece in the whole solution generating process regarding sustainability and environmental health challenges, is that we have to keep talking about it, right? You should never shy away from the conversation and have those healthy arguments with people who might have different views so that you can create new knowledge but still keep talking about these important issues.
Thank you, Monica, for the shout out. I'm right with you on that. And so our next comment comes from Amanda Henderson, joining in from the east coast of Australia near Sydney. Wow. There we have a leader in the clubhouse in terms of who's calling in from Parliament. Amanda, I think your lead is safe. All right. And Gabrielle from Houston says, will this be available to watch at a later date because I have to leave early? Sorry, Mr. Gabrielle. Yes, this is available on our YouTube channel. Will be later tonight. Leah asks, how do you think this can affect minorities medically? Are there double standards for what is considered healthy because of this? So yeah. Maybe I would reframe it another way, similar way maybe. There are disproportionate effects of these health impacts on underrepresented minorities, right? That's the heart of environmental injustice. Does it carry over further to the actual treatment once afflicted with these harmful impacts?
Wow, so this is a really important question. The first thing I want to make crystal clear is that social determinants, right? Income, minority status, levels of stress, food deserts, right? These social determinants of health are the number one indicator of health outcomes, right? And so we need to, that's one thing that's really, really important to realize. The second thing is that because of how our environment might be, right? We might be exposed to more pollutants, right? And we might develop disease more frequently than others. And if you go into a medical setting, are there biases perhaps, or are there differential acts in treatment based on being minority? If I think that's kind of coming out of the question. And I would say that there have been, which is why there's been great efforts to do what people have called, originally it started out as like cultural competency training, right? So that like people knew how to engage and recognize other type cultures and social dispositions. What has come out also is cultural humility, right? So people are advocating and teaching others of like, it's not so much as you can be aware of like, oh, they're Mexican, they might suffer from, or they might be shyer, or they might want to be simpatico and not want to disrupt the status quo, or they're worried about immigration. It's also about what we say cultural humility and reflexivity. So I'm answering the question from a solution standpoint. I would say, yes, this has occurred. And the ways that we're trying to solve it is by teaching those in those positions, right? Cultural competency, but most importantly, cultural humility and reflexivity. That you truly take the position and you put yourself in their shoes, that you really, really look at what it might be like living under their conditions and experiencing what they're experiencing. And so that's an important thing to recognize in all of this, right? But the other big thing is having diversity and inclusion at the decision-making table to prevent this from continuing to happen. And so one of the biggest things, like, because, as a minority, as a woman, you might get like bogged down, right? People ask me like, how are you doing? Like what? And it's like, you keep going and you stay positive to get the seat at the table, because you have to be addressing these things. And we know that ingenuity and things will change as we diversify the power positions in the decision-making roles. So,
wow, great answer.
Wow, I know. Okay, good. All right, another swig of water. I guarantee you this is 44 ounces of water.
You've earned it. And the next question I'll ask while you're swigging comes from Genevieve. Which areas around the world are most impacted by this environmental injustice?
So within the United States, unfortunately, right, we have seen, if we look at some of the pioneering and like paramount research materials that's come out on justice, right? If we look at dumping in the Dixie, right, that really focused on southern part of the United States, right? Looking at, so that's a big thing, dumping in the Dixie will give you a really good snapshot of the times when the environmental justice movement kind of revved up and got going. There's also parts of Louisiana, unfortunately, that's called the Cancer Corridor, right? Where there's just so much industrial activity where they're not necessarily like where there's been like a laissez-faire or relaxing of well, I shouldn't say relaxing, but there has been emissions of high concern in that area. So it's not so much like geographically, like what are the hotspots, though there are hotspots. You could actually look at it from the challenge and the population. So for example, Cancer Corridor has a high amount of industrial activity, right? Chemical and industrial activity. Right. If you go into North Carolina, you'll have a high amounts of, CAFOs, right? Those central operating animal feeding operations, right? Where you have this high density of animals like living in caged spaces. And then those are like polluting, you have lagoons that overflow, and then neighboring communities are exposed to hog and animal waste, right? So there's some great work coming out of North Carolina on that. If we look at mining, you can see mining activity like what's going on in Peru and parts of Africa, in parts of Chile, what we see in Arizona, right? What we saw with the Gold King mine spill in 2015 in the Animas River, right? So it's hard for me to give you like a specific, the most affected, right? Australia has an abundance of mining, right? I mean, and we're very concerned with populations, but we could think about, the Bhopal disaster, right? We're in India. And so I guess what I'm I don't know how to answer that in one way, but I want to say that there are area hotspots for sure. And we can look at it from that vantage point, or we could look at it from, that's a tough one to say one, right? I don't know how, yeah.
It is. I suppose you could say ironically and sadly, there's some equity to environmental injustice because no corner of the world escapes it, it seems.
Right. I mean, by the opening statistic of our proximity to hazardous waste, right, that 1 in 4 live within 3 miles. And when we think about the justice communities, right, we do see like the designated term hazardous waste facility and the designated term toxic release inventory site. Those tend to be in the low income minority areas. So if you want, you could, right, there are very important mapping tools that have been developed. One of them is called EJ Screen. So that's a Environmental Protection Agency produced a mapping tool that will overlay the justice indicators, right? Those demographic things that I mentioned, right? Minority, race, ethnicity, income, along with linguistic isolation, populations under 5, populations over 65. They'll overlay that with pollution, right? With contaminated sites. And so what this map does is it allows you to merge them, and it'll give you a percentile, that community's percentile. So it'll say this community is at the 85th percentile, meaning that they are experiencing this community is in this range of experiencing pollution, it reports a percentile, and I'll leave it at that.
Thanks. So the next question comes from several people, all asking around the same thing. One, Ethan, Reagan, Tara, I think they're all asking a question around what policies, what legislation can be enacted that could really, for example, help limit cadmium and arsenic in plants, or even in more general sense, dangers of exposures to communities. And do you get involved in that end of the whole process yourself?
Yeah, that's a really good question. And so in terms of when we think about hazardous waste sites, one of the things is we have, it's the acronym is CERCLA, which is the central, but it goes by the Superfund Act, or the Comprehensive Environmental Remediation, I can't believe I'm blanking on CERCLA, but we'll call it the Superfund Act, right? And it's efforts to designate a national priorities list. So the list of the uncontrolled hazardous waste sites. And so people yearly will submit sites that they think should be added. They'll get rated in a system, and then efforts will go to clean up those sites. And so, for example, some of the communities in which I work with in Arizona are neighboring a Superfund site. So they have federal oversight to clean up, right? State governments will have these type of programs as well. So in Arizona, we have the state Superfund, or Water Quality Assurance Revolving Fund, which delegates money to clean up certain sites in Arizona to protect neighboring communities. When we think about toxic trespass, that's been a little bit trickier in terms of some people have wanted to use, I have 3 minutes. Woo.
And 30 more questions.
How about, I'll leave it at that. So for example, you have CERCLA, and the Superfund Reauthorization Act of 1980 that has designates funding for cleanup, and also has designated funds for the Community Right to Know, which supports the Toxic Release Inventory site, website, which maps releases by companies that have 15 more employees. So I'll highlight those two. Yeah.
Thank you, Monica. There are tons of good questions here left.
Oh no,
guys, you have really good questions. One is really standing out to me. When I first read it, I thought it was a typo, but I have to ask it. It's from Lisa. She asks, can you dance the data? What are ways to communicate, especially across languages, but also cultures?
That is so, okay. So Lisa, raise the roof, because one of the things that I was very excited. So one of the things in the current NSF grant that I have for Project Harvest was, one of the research questions was, do you see different learning outcomes based on a traditional data communication or visualization versus a non-traditional or art infused? And so the way we set it up is we divided the communities, right? So we do these data sharing events, and half the community gets a booklet only with some data visualizations that aren't traditional, right? But they're a figure, right? A graphic figure. And the other half get the booklet and a art experience. And so this is where a big shout out to my student, and who just got their master's in fine art, Dorsey Kaufman, who worked and did something called ripple effect. And that's where we took the environmental monitoring data, the concentrations of metals, in this case, the concentration of the contaminants in the rainwater, and we converted it, had it on a flash drive, and it would play on a speaker. It would basically vibrate a speaker, and we had a dish of water on that. And so community members could see if the more vibration of the water, the higher the concentration. And then when we wanted to compare to exceedances, we had a light go off. So they would see vibration and a light would go off, could show exceedance. And so we're working on writing up that manuscript right now of the learning differences based on those two outcomes. And if you want to look at Dorsey's project Ripple Effect, you can just look up Ripple Effect. So dancing, of course. I personally would love to start dancing, but this is where we let the water do the dancing.
And I would too, but I really enjoy dancing, but I'm terrible. So the data would be no good if I danced it. Thank you so much, Monica. That was a real eye-opener. Really appreciate it. Thanks, everyone, for all your questions. I'm sorry we ran out of time, but you could find Monica on the web. And let me just tell everybody, you could follow us on social media to receive updates about our spring talks, and visit our website to watch our previous talks. Let's hear it for Dr. Monica Ramirez. We really appreciate you being with us tonight. Have a wonderful night, everybody.